Everyone today knows about NVIDIA and that it is making huge profits in the world of AI. Even though companies like NVIDIA have been around for a long time, they were mostly known well by gamers and hardware enthusiasts. But today, due to the massive demand for GPUs, primarily driven by the ecosystem of AI, NVIDIA has become one of the biggest companies in the world. But why are GPUs actually needed for AI? Why are CPUs not sufficient for this, even though there isn't any graphics involved in AI? Let's find out. At first glance, this seems confusing. AI doesn't render video games. It doesn't draw 3D objects on your screen. So why are we using graphics cards? To understand this, we need to look at what AI is really doing under the hood. At its core, modern AI, especially deep learning, is just math. Lots and lots of math. When you interact with an AI model, it is multiplying large matrices, adding numbers, applying simple mathematical functions, and it does this millions or even billions of times. So the real question becomes, what kind of hardware is best at doing massive amounts of repetitive math? Let's compare two types of processors. CPUs can do multiple calculations in parallel, but only across a small number of very powerful cores. And the reason for that lies in how CPUs are designed. A large part of a CPU is not just computation, it's control logic. Things like branch prediction, caching, out-of-order execution. These help CPUs handle complex, unpredictable tasks very efficiently. GPUs take a very different approach. Instead of spending space on complex control logic, they dedicate most of the chip to pure computation units. This allows them to pack thousands of smaller cores into the same area. So, while a CPU is optimized to make a few tasks run very fast, a GPU is optimized to run many tasks at the same time. Think of it like this. A CPU is like a few highly skilled chefs preparing complex dishes one at a time. A GPU is like a massive kitchen with thousands of workers, each doing one small step, very fast. Now here's the key insight. AI workloads are highly parallel. For example, if a model needs to multiply two large matrices, each element can be computed independently. That means one operation doesn't depend on another. Everything can happen at the same time. And that is exactly what GPUs are built for. Instead of doing a limited number of specialized computations at a time, GPUs can do millions of similar computations simultaneously. This is why training AI models on CPUs would take months, while GPUs can do it in days or even hours. But do we always need GPUs? Not necessarily. There are two main phases in AI. First is training. This is where the model learns, and it is extremely compute-intensive. GPUs are almost essential here. Then comes inference. This is when the model is used. Sometimes CPUs are enough, but for large models or real-time systems, GPUs are still preferred. So GPUs are not always required, but for modern AI, they are often unavoidable. You might wonder, why not just make CPUs more like GPUs? The reason is trade-offs. CPUs are designed to run operating systems, handle unpredictable tasks, execute complex logic efficiently. If we turned CPUs into GPUs, they would lose flexibility. Many everyday applications would become inefficient, so instead we use both, CPU for control and logic, GPU for heavy computation. Here's the bigger takeaway. GPUs were originally designed for graphics, where millions of pixels need the same computation applied repeatedly. It turns out, AI has the exact same pattern. That's why GPUs became the backbone of AI. Not because they process graphics, but because they are incredibly good at parallel math. So the next time you hear about GPUs powering AI, remember, it's not about graphics. It's about scale, parallelism, and raw computational throughput. And that is what makes GPUs indispensable in the world of modern AI. Give a thumbs if you like this video and subscribe for more.